Alright, just as I had hoped, Friday morning, and the parts have arrived. So, got my 4 new electrolytics, and for the 10 microfarads, I went with plastic film. Why? Well, basically because I could. So 10 microfarad, 100 volt axial, so they'll mount in just like the old ones. Sure, I could have gone with more commonly available radial 10 microfarad, but they're just so small and you got to bend the leads around. So for a few bucks more, I was able to get these. Plastic film will last forever, and I don't have any trouble mounting them in there. Same with the electrolytics, I got all axial. So for example, here's a new 1000 microfarad, 16 volt, 105C, long life, high reliability capacitor. So, not as easy to find, but the axial caps are still out there. Here are the 2 new 10 microfarad caps installed. But before I can replace these electrolytics that were up here, I want to remove some corrosion. One downside to using caps with a cardboard outer covering is that they can hold moisture, and that right up against this metal, even though it was cadmium or zinc plated, eventually caused some corrosion, especially way down under here. So maybe another hour or so with the navel jelly, and then I'll smear on some T9, and then finally install those caps. Alright, that should do it. All the electrolytics have been replaced. While I got it out, I think also a little cleaning and lubrication, like on this big plunger assembly. The old grease looks pretty dried out down in here. So the question then will be, well, one, does it still work? Did I mess screw up? But also, with these new components, can I get it to calibrate correctly? My biggest concern would be replacing the seleniums with more efficient silicon diodes. Not so fast. There's still a little matter of replacing the old crunchy power cord. I've already cut it off and removed the remains. For a replacement, I figured I would use this guy, probably from one of my Dell computers. I just had it hung up in a closet with my other spare power cords. So it's rated for 10 amps, 125 volts, so more than sufficient. I've already cut off the old end, which would have plugged into something like this, which I believe they call an IEC connector. Now, what I was a little surprised by is what I found inside. I was expecting to find a white neutral wire, a black hot wire, and a green ground. Instead, I've got a blue, brown, and a green with a yellow stripe. Well, a quick search on my phone revealed that that is the IEC standard. The green-yellow is ground or protective earth, as they call it. Blue is neutral, and brown is hot. So that is how I will hook it up. As for how it gets hooked up, recall in the earlier segment I was saying that there's no ground symbol shown on here on the schematic. Well, there is actually one. It's right here. It's the earth or ground from the power cord goes to the frame of the tester. Not electrical ground. It's not connected to anything inside. It's just there to protect you in case something inside does make contact with the metal frame. Neutral goes off into the wiring, and the black hot goes directly to that 150 watt light bulb, and then through various switches for the powering the set. In fact, the set really doesn't get power until you put a card in. Well, there's both a switch on the front to turn it on, but it really doesn't also turn on until you insert a card. That's what the solenoid and micro switch is all about here. So anyways, I will strip off the ends, and hopefully I can reuse this little strain relief thing here to keep the cord from getting yanked out. So get this through the hole. The old O-ring is in fine condition. Let's see, I just completely forgot what I just said was hot and neutral. Alright, neutral is blue, so blue goes directly to over here, and the brown will go to the light bulb, and that will go over there, so put in my strain relief right about here, I will be fine. Okay, before I do the calibration procedure, I'm just going to dive in and try to test the most common tube I have, is 6AU6. Even if the calibration is off a little bit, it should still be in the ballpark. It should still work okay if everything is alright. So, first off, turn it on. I got it plugged into my PR57 Variac. Turn that on. Alright, so nothing is shorted out. Drawing, basically no current, because as I said, until you put a card in, there's another AC interlock in series with this switch, so nothing has actually happened yet. So, I'll put in a card. That's not a good sign. It should have gone. It's like there's no power on this. Should have gone ka-thunk when I put that card in. Was the solenoids engaged? Well, let me try one of these loose cards, just to make sure I have it in all the way. Alright, something is not right. So, power cord could be bad, it seems unlikely. Or that light bulb may be loose, or may have just burned out, because I do have a dead short somewhere. So, I'll plug this first off. Let's take a look at that light bulb. Green going to frame, blue going off into the circuitry, and brown going right into the light bulb. The reason I suspect this a little bit is that so this wouldn't loosen up over the years, they put some goo in the base here and some friction tape, so I might not have had this in all the way. Plus I think it may have corroded a bit over time. So that is my first suspect. So let's just see if we got continuity on that bulb filament. You guys can see that, I think. Yeah, bulb's still good. I'll clean off that base there a little bit. That sandpaper. And it's a little corroded on the contact on the other side, so I'm going to clean that out a little. And then, let's see what can I use for that. I'll drive that bulb in as firm as I dare. I don't want to crack the thing. Use a little Simichrome and a Q-tip. Could use some deoxit too. And now I'm going to check for continuity in the socket. Should be about 7 ohms, like I got when I tested the bulb directly. Nothing. Some clip leads on that and tighten the bulb while I watch the meter. A little nerve-wracking because that bulb is in there really tight. If I want to break the thing off. Broken glass going everywhere into my hand. Oh, there we go. Okay, there was a tight spot. Once I got past that, then it was easier to turn. Okay, let's try this all again. Well, you may notice I have a couple books under here. There's some of the stuff mechanism in the middle kind of hangs down, so I want to have some clearance under there, so the ends are just supported by these books. Okay, so plugging it on. That's more like it. But that's not. Need to work that new grease in a little bit, I guess. Alright, so back to the 686. For those of you not familiar with the Cardmatic, maybe we should take a step back. These were designed to streamline the tube testing process. So the only control you've got to set is line adjust. The filament voltage, the load, the bias, that's all set up by the card. Also, for two section tubes, like a dual triode 12AU7, you can test both sections by manipulating these push buttons. You don't have to change any switch settings. So, for example, line adjust, rotate this. Alright, so that's working correctly. So rather than have a variable control for line, they just have fixed switch positions. You can usually find one that's close enough. Alright, now I'll pop in my 6AU6. So by streamlining, not only do you have to flip any switches, but like for the shorts test, all the lights are right here. There's no rotary switch for the shorts test. One thing you have to do is check the line adjust again, check for gas, and check for quality. That's it. So, assuming this is calibrated and working correctly, that's a good tube. So it does seem to be working correctly. I know that's a good tube. Now, one thing I'm just anxious to try, so I'm going to do before I calibrate it, is check one of the 4 12SN7s in my ongoing National TV7W restoration project. All 4 of those tested bad in this tester, but tested good in my Hickok 600A. Something else kind of unique with these testers is that for a given tube, like a 12SN7, there may be more than one card. I've got 1 card, 2 cards, 3 cards. What are these for? These are different operating modes. So one may test it as a triode, one may test it as an oscillator, one may test it as an amplifier, one may test it as an oscillator, one may test it as a rectifier. Fortunately, I don't have any guide that tells me which card is which. All I can tell you is that if you really want to test the tube thoroughly, go through all 3 cards. And notice there's a light over here. That's because this is a dual tube, so there's 2 sections to test. Alright, pop that guy in. Yes. Ah, that's a good sign. Now they test good. When I tested them earlier, they were down at around 40 on the meter into the bad. So, I hate to think about it, but I may very well have tossed some tubes that were actually still good because they showed bad in this tester, which I was trusting. Alright, now I'll go through the calibration procedure. They give you just 1 card, as memory serves, and it's a pretty quick process. three controls. One is to adjust the short sensitivity, and then a DC and an AC cal. I just need to find the calibration card somewhere. Test card. Ah, I finally found it. I thought it was in my stack of loose cards, but at some point I must have stuck it at the beginning of my set of cards. So here it is. Now, one thing I should point out, I haven't already, this is a Model 121, not to be confused with the Model 123, which is far more highly thought of and collectible in the community. It has, it's a little more elaborate with the tests it can do, and it's also compatible with some other Cardmatic testers from other manufacturers. So much so there's actually an online database of all the cards where collectors have scanned the cards, which allows you to punch out your own. No such database exists for the 121. We started to try to get some interest in this going at Video Karma, and scans of a few cards were provided. So you may have noticed that there are sockets on this side for the old tubes, 4, 5, 6, 7 pin sockets. I don't have any cards for those tubes. The standard set of tubes that comes with this is just for the common TV and radio tubes of the late 40s into the 50s. That's it. None of these older type tubes. However, mine did come with a list of every available card, so I know what was available. This is the standard set. This is what I've got. But the full set includes all the old tubes, type 27, type 45, type 80, all that good stuff. But what nobody knows is, do they exist? Did anybody actually ever order them? And does anybody still have any? If not, yeah, theoretically it's possible to study the schematic, reverse engineer it, and figure out how the holes are punched on the cards and recreate them from scratch. And I've played around with that briefly. For example, I have some cards for, say, like a 3AU6, a 4AU6, a 5AU6, a 6AU6, a 12AU6. Everything is the same except for the filament voltage. So by using that and comparing it to the schematic, I can kind of figure out what the holes are for the different filament voltages. But it's really tedious. And I just haven't had that much of a need to do it. But who knows, if enough interest grows in the 121, maybe we can get a little community effort going in that regard. Now, calibration procedure. I haven't done this in a while. Refer back to this. I remember it being fairly easy. Irate. Connect the line cord. Power it up. Insert the calibration card. Monitor the line voltage. With the plug, well, that's no problem. I got it on my PR57. Do the line adjust. Put that on. Depress push button 2. And we should see 45 on the scale. Oh, it's pretty close. I just got to tweak this control until it's on 45. That's it. That's all you have to do. Very, very simple. So just grab the screwdriver. 2, 45. And done. AC calibration. Push number 1. And it should be on the line test. Only off a little bit. And done. And now the shorts sensitivity. I don't even use this for that. So we're done with the calibration card. That's all you do with it. Now we're going to calibrate these shorts lights. Now for this, you're supposed to connect a 10 mega ohm resistor between a couple pins on one of the sockets to simulate a tube that's got some leakage. You're supposed to use the card for a type 12BY7. These cards can either be connected with these screws and sort of a rivet to keep them bunched up so I can keep them all numerically sorted, or some I've just got loose off of eBay. These are all duplicates. And these are all for the series strung TV tubes, basically. 2, 3, 4, 5 volt series strung tubes, so not much interest in those. Alright, I need a 10 meg resistor. Okay, they said to connect a 10 meg resistor between pins 1 and 2 on any convenient tube socket. So I took one of the older type and stuck some banana plugs in there, clipped them up to a 10 meg resistor. Now you're supposed to adjust sensitivity until these lights just start to flicker. You'll notice 3 of them start going before the others. There are some 30 meg resistors in there that may be slightly at a tolerance. They're really, really, really hard to get at. It's too bad that that 5th one at the bottom, I gotta go up really high to get that one to go, but go with that. Oh! You're supposed to do it until just the top 4 go. The bottom one is supposed to be more sensitive. That's the cathode one. Okay. So I want that bottom light to be off. I think right there is good. Now I do a 20 meg resistor. And all the lights should be off. I don't think I've got one, so I'll put 2 10s in series. Okay, and they're off. Right, good. And that's it. It is now calibrated. Now that it's calibrated, I'm going to retest those 12 SN7s. There we go. Quality good. Check the other side of the tube. Quality good. So, looks like I came close to tossing 4 good 12 SN7s because I had not serviced my tube tester. So I definitely recommend, if you got an old tube tester that you've been trusting all these years and it's never been serviced, or it hasn't been serviced in a long time, take a look. And if you come across one of these Cardmatic 121s, 123, at a reasonable price, you might want to take a chance on it. Just keep in mind the cards for the 121 are not easy to come by. Good. Good. Alright, well, I hope you enjoyed this video on servicing Hickok Model 121 Cardmatic tube test.